Okay, in the last few videos we've been talking about the independent samples t-test. We used Excel to compute a p-value of 0.2195, etc. And we talked a little bit about what a p-value is conceptually speaking. Now this is going to be a quick video on how to run a t-test using the statistics software called R. You can see down here in my dock I have R installed already. I'm not going to teach you how to install R because that's going to depend on your machine, but if you Google it, there are tons of tutorials on how to install it on your computer, and by the way, R is totally free and does any type of statistics thing that you would ever need in advertising or marketing related research, until you get up to super advanced, very industry specific things. But a lot of businesses use R for everything. So we'll use it here. Just want you guys to be familiar with it. And we won't do every statistic in this class with R, but we will sprinkle it in for some of them. Okay, so first off, we have to have our data represented in a different way. So when we computed the t-test, we had group A and group B represented like this. I made another file and I called it t-test-data-for-r.csv. That's available on the course website. And if you look at what that looks like, it's a CSV file, so it's comma separated values, and we have two columns, group and exam score. Now these are the same sets of exam scores where I've labeled group A as 1, and I've labeled, let me zoom in on that so you can see better. I've labeled group A as 1 and group B as 2. And you can see these are the same set of scores that we had in the previous file for group A, and this is the same set of scores for group B. And so in any statistics package, there are many of them: SPSS, SAS, Stata, or Stata, I'm not sure how to pronounce it, R. There are other packages. This is how you would want your data organized, so that way you could do an independent samples t-test. So how do we load this file into R? Well, first we open R up, and we use a function. You can see my cursor is blinking down here. I have to type in read.csv, and then this little arrow thing. Excuse me, I did that wrong. We're going to name a variable. We're going to call it my data, and this is going to be a name of something where we're putting our data, and that little arrow things, we're going to assign a set of values to my data. We're going to say read.csv, and in parentheses within quotation marks, we need to know the exact location of this file on our computer. So in a Mac, I'm going to go to get info, and it says where, and I can highlight that entire path, and then I can Control V, paste that into here, put another /, and I know the name of the file is t-test-data-for-r, so I can Control or Command C, Command V, and so now I have the full path to the file, and I press enter, and now I have something called my data, and if I look at it, it looks like what we saw inside that Excel file, that comma separated values file. It added an extra variable over here to the right, probably because I had some spaces or something messed up, but it doesn't really matter. So now we want to compute our t-test using R. So remember how hard this was in Excel. R makes this easy. We just have to type in a few letters. So the way we do that, it's got a function called t.test, and I just say, okay, I want to test, so my data, and then I put a $ for which variable I'm wanting to test, exam score. Then I put a little tilde, which sort of means like, okay, it's going to be this one variable by this other variable. It's going to be my data $ group. And that gives us some output you can see here. It says Welch two-sample t-test. We got our t-value of negative 1.272. And if you remember, when we computed it by hand, we ended up with a t-value of negative 1.272. We have a degrees of freedom that it's estimating differently. You can just take me on blind faith that you don't need to pay attention to that yet. And a p-value of 0.2221, which is not exactly what we did here because it's doing a slightly different style of independent samples t-test, but close enough to not really be very meaningful. And you can see the means here, 48 and 65.4, are the same as what we computed before. So we can conclude, we can look at this p-value and we can interpret it the exact same way we've been interpreting our p-values before. We can say that if we assume that there really was no difference between, or in this case I had labeled it exam scores, right? But this could be anything. This could be IQ scores. This could be how many people donated on website A versus website B. This could be people's ratings of logo A versus people's ratings of logo B. If we assumed that there was no difference between those two groups out in the population at large, if out in the population at large those were truly equal, and we did this study 100 times over, we would end up having we would end up getting positive results. We would end up seeing a difference this large about 22% of the time. So that's how to do a t-test in R, and I will be on standby if you need me. See you soon.